Hello, welcome to Simply Math. Last time I showed you how to find a quadratic sequence by hand. Today we'll look at the same example but using a calculator. So for our first example right here, this is the rule that we found in the last video, which I'll link in the description box below. However, to find this rule in the calculator, you will need to go to Start. This should work for any calculator that have the start or the list function. So when you go to Start, you enter in Edit. And I actually already put a number in here. For list 2, it is your sequence. L2 is your sequence. And then L1 is your n. And so n in this case would be 1, 2, 3, 4, and 5. After you enter it, you just need to hit Start, go to Calculate, and you can see Quadratic Regression right here. Just enter, make sure X is list 1 and Y is your list 2. So you just enter, and it tells you right here. So you can see this is the general formula. It tells you that A is 4, which is 4x squared. In our case, the variable is n. And then -2 for B, so minus 2n. And that is what we found in the last video. On the other hand, if you already found the rule and just want to check if you're right or not, you can go to y equals and type in the formula. So 4x squared minus 2x. You can graph it, but in this case, I just want to show you the table. So as you can see here, 1, we have an output of 2. For n is equal to 2, we have output of 12, and then 30, 56, and 90. And that's how you can tell you got the right general rule for the sequence. We can test it again with the other example. The calculator will not show you this whole formula. However, as I said in the last video, you can work with the numerators and denominators individually. So for the denominator, we're gonna have 2, 23, 58, 107, 170. So then again, our n is just 1, 2, 3, 4, and 5. So to check what the rule is, we're gonna go back to Start, Edit. I'll change the Y or the L2. 58, 107, and 170. Then you go back to Start, Calculate, Quadratic Regression. So it tells you that 87, so we have 7n squared. We don't have B, but we have -5 for C, which is -5. And that is what we found in the last video. Or let's say if you found out that the general rule is 7n squared minus 5. Again, we can go to y equals, click what you have earlier, and then just type in the new formula. So then we're gonna go to second graph to go to table. And then again, for 1, you have 2. For 2, you have 23, 58, 107, and 170. And then with this function, you can actually find all the terms that you need. Let's say if you found a sequence and they ask for the 500th term, what you can do is to go to second window or table set. And for independent variable, instead of automatic, you can do ask. Then go back to the table, so second graph, and you can put in 500. Y will tell you that this is the output or the number in the sequence. For the numerators, we see alternating -1 and 1. Whenever you see alternating negative and positive sign in a sequence, your general rule is -1 to the n or -1 to the n plus 1. So for our example, the first term is actually a positive. So when you plug 1 in for n, -1 to the first power is just -1. And because we have a positive for the first term, we actually need to use n plus 1, which is a positive 1. And so these two formulas right here take care of the alternating positive and negative signs. In this example, we only have a 1, so the general rule for our numerator is only gonna be -1 to the n plus 1. However, let's say that if you have a sequence of 2, -4, 6, -8, and 10, and your n is 1, 2, 3, 4, 5, you can see here that the number part itself is actually 2n, and in the alternating side, you would multiply by this part right here. So these two formulas take care of the alternating signs, and then you can multiply either one of them with the general rule that you find for the sequence. And so go back to our example. We have -1 n plus 1 over 7n squared minus 5. I hope this has been helpful. If you would like a video of any topic or if you have any questions, just let me know in the comment section below. I'll see you again next time. Bye bye.